Okay, everyone, I'm going to go over the Praxis 1 problems, and I do encourage you, even if you did get them all correct, if you will just watch this video to make sure that you know what kinds of questions are going to be asked on the Praxis, and I'll go through each one. Okay, so the first is just testing a definition. Do you know what 2 to the 6th, what that represents? And that represents 2 being multiplied 6 times. And I think just about everybody knew that was correct. So when you do that, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. For the second problem, they were testing the definition of prime, if you knew what a prime number is. So a prime number is a number that only has itself and 1 that can go into it. Okay, so 2, for example, only 1 and 2 go into 2 evenly. 11 and 1 go into 11. 29 is also prime. Now, something you can do really quick is there are some things to know. If you can add digits together and the added digits are divisible by 3, then 3 goes into that number. So I'm looking at 51. It looks prime. You think it might be prime, but then when I add 5 and 1 together, I get 6. So I know that 3 can actually go into that. So quickly, that's really what they were testing. You know what prime is, and that you know that little rule of thumb. All right, so let's look at number 3, not an integer. So once again, they just want to know if you know the subsets of the real number system. So let me show you. You start out with natural numbers. Natural numbers are also sometimes known as counting numbers. So it would be 1, 2, 3, etc. to infinity. Okay, so there are infinitely many natural numbers. And then the next subset are called whole numbers. And the whole numbers system is just a little bit bigger than the natural numbers because the whole numbers just includes 0 with the counting numbers. Okay, so I'm going to show, it's kind of like a pond with ripples in it. So the whole numbers encompass all of the natural numbers as well as 0. That's the new addition. Then after whole numbers, then you have integers. So with integers, you have all of the natural numbers, all of the whole numbers, and now we're going to include negative numbers. So we'll include things like -3, -2, -1, 0, 1, etc. Okay, infinitely many of them. Integers. After integers, we have rational numbers. So we're going on because I just want to make sure, because other questions could entail some of these. You need to know the definitions of all of these subsets. So rational numbers includes, of course, all of the integers. So we're now to positive and negative and 0 numbers, but now we include fraction parts and numbers that can be written as a decimal, and the decimal is either repeating or terminating. So, we're looking at numbers will include -1, -1/2, 0, 1/2, 1, etc. Okay, both directions. Infinity, negative infinity to positive infinity. Same with integers that went from negative infinity to positive infinity. Whole numbers has a direct starting point at 0 to positive infinity. Natural numbers 1 to positive infinity. And again, the rational numbers are the only ones that include fractional parts. So that's rational. Okay, fractional parts. And you have rational numbers. Then you might remember that there are also this subset called irrational numbers, and it's outside of this pond. They don't include any of these because it's either rational or irrational. And irrational numbers are numbers like pi, e. If you had higher level mathematics, you might have remembered e. The square root of 2 is also one. The cube root of 5 is another example. And all of these are irrational numbers. That means that it cannot be written as a fraction, So if it is a decimal, then the decimal never repeats and it never ends. It's irrational. Okay. And all of these make up the real number system. All of these together. Okay, so now which one is not an integer? Now remember, integers are only positive and negative numbers and zero. So if we see any kind, this is a rational number. That's a rational number. So it is not an integer. The rational numbers, we have infinitely many rational numbers that are not integers, but all of the integers are also rational numbers, as are the natural and the whole. All right, so that's how you figure that one out. And that's just in case there are other questions of this type that you might see again. So now you see the whole real number system that you need to know and understand. Okay, let's look at number 4. Number 4. Number 4 says, which of these numbers is not a multiple of 7? So they're checking to see if you understand what multiple means, and they're also checking to see if you know your facts for 7. So multiple means that, you know, 7 can go into it. So if I have 7 times 1, that's 7. Another multiple of 7 is 7 times 2, which is 14. And 21 and 28, etc. So I'm looking at this. So that is a multiple. 7 is 27. Now we know that 21 and 28 are both multiples of 7. 27 lies in between them, so it is not. That is the one that is not a multiple of 7. 7 times 6 is 42. 7 times 11 is 77. That's what it means to be a multiple. Just about everyone got that correct as well. Now, number 5 was about the commutative property. Which one represented the commutative property? Okay, so let's look at this one. The answer was B, whichever one that was, but it's not. Tonight, I just want to make sure that you know, or today, whenever you're watching this, I want to make sure that you know what these mean: commutative, associative, and distributive, because you'll see all of these on the Praxis, or any of them can show up. So the commutative property, think about commuting from one place to another. So whether I go from home to work or from work to home, as long as I follow the same path, then it's the same. The distance is the same. So A plus B is the same thing as B plus A. You know that. You know that to be true. And it also holds true under multiplication. A times B, 2 times 3, for example, is the same thing as B times A, 3 times 2. Okay, so those are both the commutative property for addition and multiplication. Now, it's important for you to know that subtraction does not hold true. So in other words, 2 minus 3 is not the same thing as 3 minus 2. 2 minus 3 is -1. 3 minus 2 is 1. They are not equal. So you don't have commutative property over subtraction. The same holds true with division. So 1 divided by 10 is not the same as 10 divided by 1. In this case, I have 1/10, 1 over 10, 1/10. 10 divided by 1 is just 10, and 1/10 and 10 are not the same. So the commutative property does not hold true for division, only for addition and multiplication. The associative property. So when you think about associate, you know, pay attention to the root words. Associative property, you think about, you know, who's associating with whom. So let's say that I have 3 values. And it doesn't matter who I associate together over addition. I can either put A and B together. Again, addition is taking place. Or I can put B and C together, and it won't matter. The sum will stay the same. The same holds true with multiplication. A times B times C is the same thing as A times B times C. Okay, it doesn't matter which two you multiply together. If all the operations going on are multiplication or addition, then the associative property holds true. These would be the same. Equality holds. Again, does not work under subtraction or division. Distributive property. Okay, so the distributive property just means that if I have A times B plus C, then I can distribute this multiplication of A to both B and C. So it would look like A times B, a lot of times. How about if I just write it like that? AB plus, I'm also going to multiply C by A and get AC. All right, so the answer here was B. I know I don't remember what it was, but what I care about is that you know and recognize these three properties: commutative, associative, and distributive. All right, let's look at number 6. Number 6 was 6 through 8, 6, 7, and 8, and quite a few people got these incorrect. So I need to make sure that you understand what it means to be an additive inverse and a multiplicative inverse. So an additive inverse, by definition, means that when you add the two numbers together, the result will be 0. When you add them together, the result is 0. So, for example, if I want to know what the additive inverse of 3 is, the additive inverse is -3, because I know 3 plus -3 gives me 0. Okay, this is important if you think back in algebra. If you had something like x minus 2 equals 17, and you needed to solve this, and when you were thinking about it, and if you couldn't think of this number, I mean, this is a bad example because you can think of who this number is going to be, but you might have been taught back in Algebra 1 that you needed to, in order to get rid of this 2 that's being subtracted, you needed to use the additive inverse to both sides. So in this case, since it was a 2 that was being subtracted, we were going to add 2. And the reason why is because it made that 0, and so x was left by itself. So it was 19. So that's the reason why it's important to remember an additive inverse. And this example might help you to remember when you've used it before. Additive inverse. Okay, so a multiplicative inverse is when you multiply two numbers together, the result is 1. Now this is important. Look, additive inverse, you want them to be 0 because 0 added to any number is itself. The same thing is true for the multiplicative inverse. Any number multiplied by 1 is itself. So that's what it means to be an additive inverse or a multiplicative inverse. Okay, so let's look at this one. So let's say that we have the number 1/2. Well, I need to figure out what can I multiply 1/2 by in order to get 1. Well, I need to multiply it by its multiplicative inverse, which is 2 over 1, or just regular old 2. Okay, so that's the multiplicative inverse. It's what I get when I multiply them together to get 1. And again, this was important think of an algebra example from way back in the day. If you had something like 3x plus 4 equals 10. Well, then you had to first use an additive inverse of positive 4 to both sides because it's an equation. So then plus 4 minus 4, that gave us 0, which was the additive inverse. And then I have 10 minus 4 is 6. And then the next thing you needed to do was to get rid of the 3, but actually what we're doing is we're just going to multiply both sides by the additive inverse, multiplicative inverse, which is 1/3. 1/3 times 3 is 1. See, that's what we wanted. And then 1/3 of 6 is 2, but Anyway, I bring this up because I want you to remember you had this before back in Algebra 1 many years ago. And I'm just trying to connect things in your brain to help you remember the difference between an additive inverse. It's when you add them together to get 0. Multiplicative inverse, when you multiply them together to get 1. Because I know it gets very confusing because you think, oh, is this like you change the sign and you flip it over? I mean, it gets very confusing because math might have become for you memorization, and then memorization is easy to forget. So I'm trying to show you ways to kind of get back into your brain to think about why it makes sense. Okay, so let's look at these problems then that you had. So number 6 was the additive inverse of -1/2. See, they tried to trip you up here by making it a rational number. But the additive inverse, I'm looking for what? Do I add to -1/2 to get 0? And -1/2 plus 1/2 gives me 0. Okay, so the additive inverse is 1/2, which I think was option B. Multiplicative inverse of 16. Okay, so this is asking me multiplicative. So I'm thinking of 16 times something and gives me 1, because 1 times anything gives me that anything. That's what I'm trying to get, is 1. So when I multiply 16 by 1/16, I get 1. 1/16 of 16 is 1. So this is the multiplicative inverse of 16. What's the multiplicative inverse of 7z? Again, trying to trip you up because they noticed you're wanting to just do like -7z or something like that. You don't want to do that. It's not an additive inverse. It's the multiplicative inverse. So multiplicative means I have 7z. What is it that I can multiply by that to give me 1? Because 1 multiplied by anything gives me that anything. So all I do is I take 7z and I'm going to multiply it by 1/7z. And when I do that, I get 1. Notice if I use -1/7z, I get -1, and that's not what I want. I want 1. I don't want it. I want the identity. Okay. For multiplication, the identity is 1. For addition, the identity is 0. And that's what you're going for that, to figure out what do I need to be equal to for additive inverse equal to 0. For multiplicative inverse, you want to be equal to 1. Okay, make sense of it. Make sense. Try not to resort to memorization. Let's make sense of math along the way. Okay, that's it. I'll do the next one after I get everyone's responses for Praxis 2.